Hi everyone, this is Adam again. This is going to be hopefully the last video of paper 1, higher level Lebensart Maths. So yeah, without further ado, I suppose we may as well start. So this chapter, which is the very last one, is basically integration. Now integration is basically just the opposite. So for all intents and purposes, what you're doing is you're just doing the opposite of differentiation. Okay? So basically, if you have, so remember we were taking the differential of x squared and we were getting 2x. This is basically the same thing as saying that the integral of 2x dx is equal to x squared. Okay? Now, if some of you have done integration before, there should be a plus c. I'm just leaving it out for the time being, okay? So this is basically just saying that this is differentiation. So differentiation says that if I differentiate x squared, I get 2x. Integration is basically just going backwards. That's all. So you start off with 2x and you end up with x squared, or do you start with x squared and end up with 2x? So basically, differentiation is for slopes. Integration is basically area. That's basically what integration is. Okay, so when you integrate a function, you're basically getting the area underneath the function. Okay. Again, you won't ever need to show that or anything. It's just you need to know it. So because they definitely could ask you, what is the integral of this thing, and then what's the area underneath this curve, and then you'll have to know, okay, I need to integrate, But for the time being, so basically starting off, what I'm going to do is basically, for my first part, I'm just going to say, okay, well, if you differentiate a function, so let's say you get d dx of f of x, and let's just say you get g of x. Okay? Now, if you integrate g of x dx, you should get f of x plus c. Okay? So in integration, we have this thing plus c. The reason you have to do plus c is you're adding a constant. Okay, so a constant basically is, it could be 1, it could be 3, it could be minus 2.4, it could be whatever. Just the thing is that if you're integrating, you always get this thing called a constant of integration. Basically, because if I tell you the derivative is 1, and I ask you, okay, what's the integral? What did I differentiate to get 1? You could say x. But I could say, hold on, well, if I differentiate x plus 7, that's also going to give me 1. I could also integrate x minus root 3. On and on and on. And therefore, the correct integral, or antiderivative, is x plus c, where this c is just some constant. Okay? So, just for example, if I ask you f of x equals sine x, and then I say, okay, well, what's the differential of sine x? So d dx of sine x equals cos x. Great. So now if I asked you, what is the integral of cos x dx? The answer is sine x plus c. Okay? So again, just remember that, integration, if they ask you to integrate a function, the way you should think about it is you should say, okay, what is it that I have to differentiate to get this? Okay? So if I asked you, what's the integral of x squared? What would you say? you'd say, well, okay, we definitely have a plus c anyways. And then you'd say, okay, well, what do I have to differentiate to get x squared? Well, if I differentiate x cubed, I end up with 3x squared. But I don't want 3x squared, I just want one of them. So I just need to divide this by 3. Okay? So that's kind of how you solve these. Okay? So another thing, I'm just going to give a couple of rules here. If you want to integrate x to the power of n, this is always equal to x to the power of n plus 1 all over n plus 1 plus c. Okay? And you can probably see that from here. You have a 2 here, you have a 3 and a 3. You have an n here, you have n plus 1 and n plus 1. Okay? Same thing, if I integrate e to the 3x. So remember, for any exponentials, if you take the derivative of it, you just get the same thing. So in this case, you'd say, okay, well, this is going to be e to the 3x plus c. But remember, when you're differentiating, this thing comes down to the bottom. Because remember, you do the chain rule and you differentiate e to the 3x and you get e to the 3x multiplied by the differential of 3x, which is 3. So you get an extra 3. So I need to get rid of that 3. And therefore, it's 1/3, like this. So basically, the only difference from integration to differentiation is that you start dividing by the derivative of these things. Okay? That's mainly it. There's one special case, the integral of 1 over x dx, that's the natural log. So just remember that. Remember that d dx of ln of x is equal to 1 over x, and therefore the integral of 1 over x is equal to the natural log. Okay? So that's it. So now, one thing that I'm going to do is, again, I'm just going to fly through a couple of examples. So it says, what is the integral of 2x squared plus 5x cubed dx? So again, the x squared, you increase the power. So it's you add 1 to the power and then you divide by the new power. So the new power is 3, so you divide it by 3. It's 5x cubed, so you add 1 to the power, so it's x to the 4. And you divide by the new power, so you divide by 4. And then remember, you just add c, so you can add any constant. Okay? You can also be asked to integrate x plus 2 cubed dx. The way you do these is you'd multiply them out. So if I multiply this out, I get the integral of x cubed plus 6x squared plus 12x plus 8 dx. So now if I integrate this, so if I integrate the first one, I get x to the power of 4, divide by the new power, divide by 4, plus 6x, add 1 to the power, cubed, divide by the new power, 3, add 1 to the power, divide by the new power. Now, what happens if I integrate a constant? So before we had, if you differentiate a constant, you get 0. Now what happens when you integrate a constant? So 8 is the same thing as 8x to the power of 0. So if I add 1 to the power, I get 8x to the power of 1 divided by 1. Okay, so this is just equal to x to the 4 over 4 plus 2x cubed plus 6x squared plus 8x plus c. So just to be clear, this plus 8 give me a plus 8x. So whenever you're integrating a constant, you just end up with the constant multiplied by x. Okay? All right. Now, one more thing that I want to do is just doing displacement, velocity, and acceleration, because you can be asked it, okay? So basically, what problem do we have? So it says a ball is thrown upwards. So we have a cliff. So you have someone up here. Ball is thrown upwards. It hits a height, and then it falls down. And this height here is 144 meters. Okay? It says that it is thrown upward with a speed of 16 meters per second. Okay? The gravity, g, which is acceleration, the acceleration of the particle is 9.8 meters per second squared downwards. Okay? And this is a number that you'll be expected to know. You'll be expected to know that gravity is 9.8. Okay? That's why I'm doing one of these problems, because you are expected to know this. Okay? So, it says, explain why the acceleration A is equal to minus 9.8 meters per second squared. The reason it's equal to minus 9.8 is because gravity is going down. If we take this direction as being positive, so everything going up is positive, everything going down is negative. Gravity is going down, and therefore it's negative, and therefore you get this. Now, the next thing that's very, very important. Displacement is basically distance, which is denoted by S. That's equal to the integral of V dt, where V is velocity, and the velocity is equal to the integral of the acceleration. Acceleration is the derivative of the velocity, and the velocity is the derivative of displacement. Okay, so these are the four relations. You have to know these. They're not in the log tables. So you have to know that so here we have acceleration. Now, the next thing they ask is, say, what is the velocity of the ball? So you'd say, okay, well, the velocity is simply equal to the integral of the acceleration. So the velocity is equal to the integral of minus 9.8 dt. So the velocity, so v of t, where t is time, is equal to minus 9.8 t plus c, plus a constant. Now, this time I want to figure out this constant. There's only one constant that works. Why is there only one constant that works? Because you're told the initial velocity is 16. What does that mean? That means that if I plug in 0, so if the time is 0, so initially, this has to be equal to 16. If I plug 0 into this, I get plus c, and therefore c is 16. So my velocity v of t is equal to 16 minus 9.8 t. Okay? And now the next thing that it says, what is the speed of the ball at the instant it reaches its maximum height? So when the ball reaches its maximum height here, so the ball goes up and up and up and up, and then it reaches its maximum height, and you're asked, what is the speed of the ball? Okay, sorry. Yeah, I'm very sorry. There's one more thing that I want to say. So I never explained what displacement, velocity, and acceleration actually are. So acceleration, now you might say you think you know what acceleration is. You mightn't. Acceleration is the acceleration in a specific direction. So it's rate of change of your speed in a specific direction. So basically with these ones you can have plus and minus. Okay? So velocity is also speed in a direction. So basically you can have plus and minus. Now the thing is, you go onto a road and you ask what the speed limit is, you'd say it's 60. You'd never say, oh, he's going plus 60 and she's going minus 60. That doesn't make any sense, okay? If they're going in opposite directions, it makes no difference. Their speed is still 60, but their velocity is different. The velocity is specifically what speed are you going, first of all, so that's the number you give them. So in this case, you'd say the velocity is going to be whatever this thing is, but then the direction is whether it's positive or negative, okay? So that's like another thing to just kind of have in your head, that velocity is speed in a certain direction. So plus basically means you're going up, minus means you're going down. Speed is just how fast are you going. Doesn't matter if you're going up or down. And then displacement, S, that's basically as the crow flies, where are you? So basically, if I walk 10 paces forward and 10 paces back, my displacement is 0, because basically displacement is like, where were you? Where are you now? How far are those 2 points away from each other? So you started here and you're still here, therefore your displacement is 0. If I asked you what distance did you travel, you'd say, well, I went 10 paces this way and 10 paces back, therefore I did 20 paces in total. Okay, so your distance is 20, but your displacement is 0. So specifically, these ones are all direction based. It's basically what distance are you from a point, what speed are you and what direction are you going, what's your acceleration and what direction are you going again. Okay, so just be clear on that. So sorry if that wasn't made clear. I apologize for that. So here what they're asking is, what's the speed at the maximum height? The answer is 0, because you have it that it's, the speed is positive, 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 because it's going up. It's positive, 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 and then it's negative because it's coming down. So at the pink point, it's exactly 0. The next thing it says, okay, so how long does it take before it reaches that point? Well, you say, okay, well, the velocity is equal to 0, and the velocity is equal to 16 minus 9.8 t. So t is equal to 16 divided by 9.8 seconds. So that's how long it takes from the ball to be thrown here to all the way up there. Okay? The next thing it asks us is, find S of t, the displacement of the ball from the top of the cliff. So S is equal to the integral of v. So now if I integrate this, I'm going to get the integral of 16 minus 9.8t dt. So again, if I integrate 16, I get 16t. If I integrate t, I get t squared over 2. So remember, you add 1 to the power, you divide by the new power. So now it's t squared, divide by 2, get t squared over 2. Minus 9.8 divided by 2 is minus 4.9. T squared plus c. To figure out what the c is, okay, so sorry, this is a different c. So this is like c1 and this is c2. So they could be the same, but they don't have to be. Okay? So it's just some constant that I'm adding on. And I want to know what is c2. So I know, starting off, the height is 0. Okay? So that means that s of 0 equals 0. If I plug 0 into this, I get 0 plus 0 plus c2. Therefore, c2 has to be 0. So s of t is equal to 16t minus 4.9t squared. Okay? And that's that. Okay? That's the end of that question. So that's just, these rules are the most important thing to have. Because again, these aren't in the log table, so you will need to know them, unfortunately. Okay? Just to have it in the back pocket in case it does come up. Okay. Now again, just a little bit of, these are more rules. So if I integrate e to the x dx, I get e to the x plus c. If I integrate e to the ax dx, I get 1 over a e to the ax plus c. And yeah, that's it. That's all you need. Okay, so just instead of, because we had that d dx of e to the ax was a e to the ax, so you can just see that here we're dividing by a, here we're multiplying by a. That's the only difference. Okay. All right. So now I'll just do one of the integrals, which I think is quite hard. Yeah. Okay. So it says solve this. So what we have is, we have the integral of e to the x minus e to the negative x dx. So if I integrate this, the first one is just going to be e to the x. The second one, so a in this case is minus 1. So it's going to be 1 over minus 1 e to the negative x plus c. So it's e to the x minus is plus e to the negative x plus c. So this is the integral of this thing. Okay? All right. Yeah, is there any other one I want to do here? They're kind of all the same, to be quite honest. Yeah, I'm going to do this one. So they're asking me to integrate e to the x minus e to the negative x all over e to the negative x plus 1. Now, this looks absolutely disgusting, and it kind of is, okay? So what I'm going to do is, whenever you're faced with something like this, you want to get rid of what looks awkward. These e to the negative x's on the top and the bottom just look awful. So that's the very first thing I'm going to do. I'm going to multiply the top and the bottom by e to the power of x. Okay, so I get the integral of e to the x squared minus 1 all over e to the x plus 1. So remember, e to the negative x multiplied by e to the x, that's like e to the x divided by e to the x, so it's just 1 and 1, okay? The top thing is a difference of 2 squares, so that's e to the x plus 1, e to the x minus 1, all over e to the x plus 1. So these cancel. So I'm just left with the integral of e to the x minus 1 dx. If I integrate e to the x, I just get e to the x. If I integrate minus 1, I get minus x. And then just plus some constant c. Okay? And that's it. All right? Okay. Now, finally, what I want to do is now definite integrals. So far we've been doing indefinite integrals. Indefinite is basically when you don't have anything up here and here. Now we can do definite integrals, because remember I said that it was area. So I can say, okay, I only want to find the area from x equals 1 to x equals 7. So you only go from 1 to 7. Okay? So one of these would be the integral from 1 to 3 of x cubed minus 64 all over x minus 4 dx. So it's the integral from 1 to 3. So the top one is a difference of 2 cubes. So it's going to be x minus 4 times x squared plus 4x plus 16 all over x minus 4 dx. So these two things cancel now. So I'm left with the integral from 1 to 3 of x squared plus 4x plus 16 dx. Now, this now, you put square brackets, or you can put a straight line down. I typically put square brackets like this. So first of all, if I integrate x squared, I get x cubed, divide by the new power. X integrated is x squared over 2, multiplied by 4 is just 2x squared. And if I integrate 16, I get plus 16x plus c. So again, we still have the plus c like usual. Now, some of you, again, if you've already done integration and you're looking at this and saying, why does he have the plus c? The value of c doesn't matter in this case. I'm just demonstrating why it doesn't matter, okay? So basically this plus c, I'm going to keep it for the time being, but we'll see in a second that it basically just disappears, okay? And we don't need it anymore, all right? So what you do is you plug in 3 first. So if I plug in 3 first, I get 3 cubed, which is 27, divided by 3, that's 9. Plus 3 squared is 9 times 2 is 18. Plus 16 times 3, that's just going to be 54. Plus c. So you plug it, this is when you plug in 3. You minus now, and now you plug in 1. So if I plug in 1, I'm going to get a third, plus 2, plus 16, plus c. Okay, so on the left-hand side, I get 27 plus 54, there should be 81. Yeah, of course, 81. 81 plus c minus. So 2 plus 16 is going to be 18 and a third minus c. So I hope everyone sees, pun unintended, that the plus c and the minus c will cancel. So basically, it doesn't matter what c is. C could be 5, it could be 10, it could be 20, 30, it doesn't matter. They will always cancel. So that's why you'll find that if it's indefinite, so when there's no bounds, you need a plus c. When there is, you don't. If you're unsure, just always add the plus c. It'll cancel out anyways. But just to know, you actually don't need to have it. And so this is just going to end up oh, did I make a mistake? Okay, maybe I did. Oh, this is 48. Sorry, this is 48. That's my bad. Yeah, so 48 plus 27 then is going to be 75. Sorry, yeah, this is 75. Okay. And so I end up with 56 and 2/3. Okay. So that's then your definite integral. Okay. So now, the next thing is to look at area underneath the graph, because this is basically what integration is. Okay. So what you're doing is, so the integral sign, this is basically a summation sign. So integration is basically just adding up. Okay. So if I integrate f of x dx, so what you're doing is, let's say f of x is this thing. What you're doing is that you're getting f of x, which is this thing, and you're multiplying it by a dx, which is here. And then you're doing f again up here, and another dx, on, on. And basically you're adding up all these areas. That's what you're doing by integrating. So let's say this is 1. Say this is 3. The integral from 1 to 3 is just this area here. So that's the idea. It's like you're multiplying a height by a small width and you're adding them all together. Okay, so that's what integration actually is. Okay, now the next thing that's important is to find area underneath a curve. Okay, so what we have is, let's say we have a curve like this, which is just going to be like this one. X squared minus 9. So again, this is 3. And they want you to find the area. They want you to find this area and this area here, where this is 5, and then this is obviously 0. And this here is 3. Okay? So, first of all, let's get the first area. So the first area, I want to integrate the function, which is x squared minus 9 dx. I want to go from 3 to 5. So that's going to give me this area in here. So this gives me, from the bounds of 3 to 5, x squared integrated is going to be x cubed over 3 minus 9x. Again, you don't have to add the plus c here, specifically because it's a definite integral. So I have bounds, so I don't need to do it. So if I plug in 5, I'm going to get 125 over 3 minus 45 minus, if I plug in 3, I'm going to get 9 minus 27. Like so. So this now is going to be, so that's going to be 41 and 2/3. Yeah, 41 and 2/3 minus 45. This in here is going to be minus 18. Minus 18 is plus 18. Okay. So minus 45 plus 18 is minus 27. 41 and 2/3 minus 27, that's going to be 14 and 2/3. So that's how much area units squared. That's how much area the first one is. Okay? So hopefully that's all right. Now, the second area, I want to integrate from 0 to 3 of x squared minus 9 dx. Okay? So again, you don't have to do the integration again. It's going to be x cubed over 3 minus 9x. The same thing as it was before. Now the 3 is on top and the 0 is on the bottom. So the 3 on top is positive. So it's going to be 3 cubed divided by 3, that's 9. Minus 9 times 3 is 27. Minus, if I plug in 0, I get 0 minus 0. So it's just minus 18. Now, hold on a minute. That does not make any sense. Because I just said that if you integrate a function, you get the area. So how is it we're getting a negative area? We were always going to get a negative area. This is one thing. Integration, so we interpret it as being area, but it doesn't know that. Integration, all it does, as I said up here, it multiplies the function by the length. So this is always greater than 0, but this mightn't be greater than 0. F of x can be negative, and in this case, it is negative. And therefore, you're multiplying something negative by something positive, and therefore you're adding up a load of negative things. So it sees all these areas as being minus. And that's why we end up with a minus here. That's the one thing when you're doing these. That's why you have to be careful, because you can't just integrate from 0 to 5. You might think you can do that, but you can't, unfortunately. Because again, it doesn't see that the area is, it doesn't know that that's what you want it to calculate, area, you know? And therefore you have to be careful. And so that's why I had to split it up. So just for the record, if I did integrate, so first of all, I'll just finish the question. So it's minus 18, but of course it's 18 units. So the second area is equal to 18 units. And therefore the first area plus the second area is going to be 18 plus 14 and 2/3. So it's 32 and 2/3. So that's the actual answer of the area. And just for the record, we can't integrate from 0 to 5, x squared minus 9, because basically this minus area would cancel out the plus area, and you'd end up with 14 and 2/3 minus 18 instead of plus. Okay, so you would have made, so this is incorrect. So you just have to be careful when it crosses the x-axis like this and it goes from negative to positive. Okay? Just be careful with that. All right? Now, if we wanted to integrate something like this from there to there, and they asked you, okay, what's the area of this? You could just, if that was 3 and that was 5, you could just integrate from 3 to 5. It's fine. Because it doesn't cross the x-axis. But here it did, and therefore I had to split it up into 2 separate sections. Okay? Because if the graph is below, it sees it as being negative area. If the graph is above, it sees it as being positive area. So that's one thing you just have to be careful of. Okay? All right. So I suppose the rest of this chapter is just doing these integrals and a few hard ones. So I suppose I might do maybe 2 more questions and then leave it at that. Okay, so what's one that's a little bit hard? This is very hard. Okay. It's asking you, so here you have y equals x squared. And it wants to know what's the area in here between 9 and 1. Okay? Now, the very first thing you do is you will split this up into a rectangle. And you will say, okay, I can split this up here and here. Can I calculate this area? Yes. Why? Because this is 1. And this is 3. Okay, because remember, this is 9 and it's y equals x squared. So what number do I have to square to get 9? 3. What number do I have to square to get 1? 1. So can I get this red area that I've marked out? Yes. I can say, well, that area is equal to 1. Very simple. Can I calculate the total area? The total area of this whole thing? Yes, it's just 9 times 3, so it's 27. Can I calculate this red area in here? Yes, yes I can. It's going to be the integral of x squared dx in the bounds from 1 to 3. So it's x cubed over 3 in the bounds of 1 to 3. If I plug in 3, I get 9. minus, if I plug in 1, I get a third. So it's going to be 8 2/3. So the area that they're looking for is going to be the total area minus these two little areas, which is -1 and minus 8 2/3. So it's -9, so it's going to be 17 1/3. Okay? So that was kind of hard. Another one, yes, this one is when you have two separate ones. So here we have this. You have the straight line y equals x. And then we're going to have some graph here where this is 2, this is 1, this is obviously 0, and then this graph here is going to be y equals x squared minus 2x plus 2. And what they're looking for is they want to know what's the area inside here. So the way you do it, you would say, well, I can get the area underneath the graph like this. I can get the total area by integrating under the line, and then I can simply minus them off each other. So if I integrate the line from 1 to 2, I get 1 to 2 of x squared over 2. Plug in 2, I get 2 minus a half. So the area is simply 3 over 2. Now, if I integrate the x squared minus 2x plus 2, and I integrate this from 1 to 2 again, you get from 1 to 2 of x cubed, square ones, x cubed over 3 minus x squared plus 2x. If I plug in 2, I'm going to get 8 over 3 minus 4 plus 4. So they just cancel. Minus, if I plug in 1, I'm going to get a third minus 1 plus 2. So it's 8 over 3 minus a third minus 1. So it's going to be 4 over 3. Okay. So it's going to be 4 over 3. And now to get the area in the middle, it's going to be the big area, which is this, minus the little area, which is this. So 3 over 2 minus 4 over 3 all over 6. That's going to be 9 minus 8, which is a sixth. And here they gave you the points of intersection. They are 1 or 2. If you didn't know that, you would simply say, okay, when are the y values the same? When x is equal to x squared minus 2x plus 2, get x squared minus 3x plus 2 equals 0. Solve this quadratic, it factorizes into minus 2 minus 1, and therefore we got that it was 1 and 2 from this. Okay. All right. Hopefully that's all okay. I do one more. There's this, and then there's average value, and then that's it. Okay. I might do just one more of these, and then do the average value. Okay. So now, let's do this question. So it says, the curves, you have two curves. You have this, and you have this. You have N, you have P. So both of these points are supposed to be on the x-axis. Find the coordinates of n and p. So first of all, this one is equal to x squared minus 4. This one is equal to 8 minus 2x squared. So I want to know basically what are both those points. So when are the functions equal to 0? It doesn't matter which one you pick, just equal this one to 0 or this one. I'm going to equal the top one to 0 because it's slightly faster. So you get x squared equals 4. So x is equal to plus or minus 2. This is minus 2. This is plus 2. So those are our points of intersection. And it says, hence find the area bounded by the two graphs. So find the total enclosed area here. So I can calculate this area and I can calculate this area. So if I integrate the top one, so if I integrate 8 minus 2x squared from minus 2 to 2, I get the top area. So minus 2 to 2 of 8x minus 2x cubed over 3. Again, plug in 2, I get 16 minus 16 minus 16 over 3. Minus, then plug in minus 2, I'm going to get minus 16 plus 16 over 3. So this will just end up being 64 over 3. Okay? So just plug that into your calculator and it'll come out to be that. And then the other area, so the white area, I can integrate x squared minus 4 dx from minus 2 to 2. Again, this is just from minus 2 to 2 of x cubed over 3 minus 4x. Again, plug in 2, 8 over 3 minus 8. Minus, plug in minus 2, I'm going to get minus 8 over 3 plus 8. This is going to be 16 over 3 minus 16, which is going to be minus 32 over 3. Now remember, again, this has come up as minus. Why? Because we are below the axis. So remember, it's just going to be 64 over 3 plus 32 over 3, which is 32 squared. Okay? And that's that. All right. Finally, the average value of a function. So the average value of a function, if they ask you what is the average value of a function from a to b, it's the integral from a to b of f of x dx divided by the length. That is the only thing you have to worry about. Okay? So it might ask you, okay, here's this function. Looks like this. It's 2x squared plus x plus 1. What is the average value from x equals 1 to x equals 4? You would say, okay, this length here is 3. That means the average value is going to be a third the integral from 1 to 4 of f of x, which is going to be 2x squared plus x plus 1 dx, which equals a third 1 to 4 of 2x cubed over 3 plus x squared over 2 plus x. So it's a third into, if I plug in 4, I'm going to get 32 times 4, so 128 plus 8 plus 4, minus 2/3, minus a half, minus 1. Okay, so if I factor out a third, if I factor out a third, I get a ninth into 128 plus 12, so 36, minus 2, minus 3/2, minus 3. So it's a ninth into 128 plus 36 is 164. 164, 159, 158, 157 and a half. And that's it. So that's the average value of this function along this interval. Okay? And I think I'll leave there for today. Thank you very much for paying attention. Goodbye.